All right, guys, here we go. Happy Thanksgiving. It's right around the corner. 10 more class days. All right, so today we're still talking about triangles. We've been talking about them being congruent. Today we're going to talk about them being similar. So in order for us to get there, we have to make sure we understand ratios and scale factors and proportions. Because if we can't do those things, then it's going to make it really hard to solve problems with similar triangles. So first thing we're going to look at are a couple of definitions. So we have a comparison of two quantities, especially division. It may look like 3 to 7 or 3 over 7, and that's called a ratio. All right, and then the next thing we have is an equation that states two ratios are equal. For example, x over 7 is equal to 6 over 14. This is called a proportion, but you already know these things. So let's see if we can solve this. So to solve this, remember you cross multiply. So you get 14x equals 7 times 6 is 42. Now we just have a plain old normal algebra equation. So divide both sides by 14 and we get that x is 3. So our answer is 3 to that proportion. All right. Now, let's do some practice just solving for x, okay? So we've got cross multiply, 12 times x, or butterfly method, maybe that's what y'all are used to hearing. So 12 times x is 12x. 84 times 7 is 588. And then divide both sides by 12. So x is 49. So our answer is 49. Now sometimes they look a little tricky, but just remember you're still going to set it up the exact same way. This negative sign here, it can go in the top or the bottom. I'm just going to put it up here in the top and we'll just get rid of it there. It doesn't matter. So I'm going to cross multiply. So I've got 2 times 3x minus 5 equals 4 times negative 13. So when we cross multiply by going that way, now we have a parenthesis so we can distribute. So we have 2 times 3x is 6x, and 2 times negative 5 is negative 10, equals 4 times negative 13 is negative 52. So if I add 10 to both sides, I get that 6x is equal to negative 42. Divide both sides by 6. We get that x is negative 7. So our answer is negative 7. And then sometimes they may even look really bad, but they're not. You're still going to cross multiply. So you get 6 times 3x minus 8 equals, go that way, 2 times 6x minus 12. So distribute 18x minus 48 equals 12x minus 24. So move the 12x over. So if I want this positive 12x to move over here, then I'm going to subtract 12x. So I get 6x. I want this negative 48 to go over here. So I'm going to add 48 because this went away. So now I have negative 24 plus 48, which is equal to 24. So this moved over here. This moved over there. So now divide both sides by 6, and you get that x is 4. All right, so now there are parts of a proportion. You have your means and your extremes. The means, this is the first and last parts. For example, the A is the first part. So A is the first part. D is your last part. So when you multiply these two, this is called your extremes. I got these backwards. These are your extremes. So let me fix this. Hope you used a pencil. All right. So the extremes, those are your first and last parts. The means are the middle terms. So these are your means. All right. Now, when you have two ratios that are equal, they're called proportional ratios. For example, if we reduce each one of these fractions, we'll find out that they're really the same thing. So if I go 120 miles in 2 hours, I really went 60 miles in 1 hour because I divide both sides by 2. It's the same thing as going 180 miles in 3 hours. If I divide both sides by 3, I get 60 miles in 1 hour. Same thing over here, 10 new triangle, 12 old triangle. Both of these are divisible by 2. 2 goes into this 5 times, 2 goes into this 6. 3 goes into this 5 times, 3 goes into that 6. So 5 over 6 is equal to 5 over 6. Okay, so think about the ratio. So anytime you see the word ratio, you're going to be dealing with things that are in common. So if my ratio of seniors to juniors, so that means I have 2 seniors for every 3 juniors. So if there are 21 juniors, then if I set up a proportion, I'm going to put 21 down here with the juniors go because that's how it labeled. How many seniors are there? So now I can cross multiply. So 3 times x is 3x. 2 times 21 is 42. Divide both sides by 3, and I get that x is 14. So that means there are 14 seniors. All right. Sometimes we use what's called an extended ratio, and this is when you compare 3 or more quantities at a time. For example, you have a triangle. The ratio of the measures of the 3 angles is 2 to 5 to 8. So that means this one is 2, this one is 5, and this one is 8. It doesn't matter. You could label them any way you want. Now, if you're comparing 3 or more things at a time, they all have something in common. And since I don't know what it is, I'm going to call it x. So they all have an x in common. Now, what do we know about all 3 angles of a triangle? Remember, they all add up to 180. So what you're going to do is you're just going to say, well, 2x plus 5x plus 8x equals 180. So 15x equals 180. Combine your like terms. Divide both sides by 15. And you get that x is 12. So now that I know that x is 12, all I got to do is go back over here and plug it in. 2 times 12, 5 times 12, and 8 times 12. And now I can find the measure of each angle. 2 times 12 is 24, so one angle is 24 degrees. 5 times 12 is 60, so one angle is 60 degrees. And 8 times 12 is 96, so the other angle is 96 degrees. So that's how you do those. So just to remember what I said, for the angles to be in a ratio, they all have to have something in common. So they all have the same thing in common, and that's x. So remember, all 3 angles add up to 180, and there you go. All right, now similar polygons. Similar polygons are the same shape, but a different size. Okay, so if I'm going to compare two, their corresponding angles have to be congruent, and their corresponding sides have to be proportional. And their scale factor is what I'm going to multiply by to get bigger or smaller. And the way you always want to make sure that you set up is new over old or new over original. And then that way the scale factor will always be right, okay? So in this triangle, ABC is similar to triangle DEF. We're still going to do the same thing, 1, 2, 3, 1, 2, 3, because that still works. So it is read, triangle ABC is similar to triangle DEF. So now let's list their corresponding angles. Okay, so A goes with D. So angle A must be congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. For them to be similar, their angles have to be congruent. Okay, now their corresponding sides, same way, 1, 2 goes with 1, 2. So AB is similar to DE. BC is similar to EF. And CA is similar to FD. So it's still the same way as being congruent, it's just now they're different sizes. All right. If you want to make something larger, then you're going to multiply by a number that's bigger than 1. So if my scale factor is 2, you multiply everything by 2. So 7 times 2 is 14. So this side is 14. 11 times 2 is 22. So this side is 22. And then 9 times 2 is 18. So this side is 18. Now what if I give you all the sides and want you to go backwards? Then you would say, well, 2 times what is 6? Because you have to multiply by a scale factor. So 2 times what number is 6? So x is 3. So my scale factor is 3. But you want to double check. 4 times what is 12? X is 3. 3 times what is 9? X is 3. So since they all have the same scale factor, then my scale factor is 3. Now, if you want to make something smaller, you multiply by a fraction that's smaller than 1. For example, 1/3. So 6 times 1/3. So I'd say 6 times 1/3 is 2. So this side is 2. 12 times 1/3 is 4. So this side is 4. 9 times 1/3 is 3. So this side is 3. Now if I wanted to find the scale factor, then I would do the same thing as I did over here. For example, 21 times what is 15? So 21 times what is 15? So I would divide both sides by 21, and I would get that x is 15 over 21. So that reduces to 3 goes into 5. 3 goes into 15 5 times. 3 goes into 21 7 times. So my scale factor is 5 over 7. It is a fraction that's smaller than 1. So 14 times what is 10? Divide both sides by 14. We get that x is 2 goes into that 5 times. 2 goes into that 7 times. So my scale factor is 5 over 7. For example, new is 5, goes with the old, which is 7. Scale factor is 5 over 7. All right, so now if we're going to prove triangles are similar, just like we did when they were congruent, we said that they could be side angle side, side side side, and there were like 5 different ones we got to choose from. Well, when we're talking about being similar, there's only 3, and that's it. But this time, angle works. If 2 angles are congruent, so if 2 angles of one triangle are congruent to 2 angles of another, they are similar. Note, if 2 angle pairs are congruent, then the third angle pair must be congruent. Because if this angle here is 50 and this one is 50, if this one is 60 and this one is 60, then these two add up to 110, and then 180 minus 110 is 70. So that makes this one 70. Well, if that one's 70, this one has to be 70. Okay? Then there's side, 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 and that means all 3 sides are proportional. Okay, just like we did on the previous page, we found that their scale factor was all the same. So that made them proportional. Okay, so for example, this is your new, this one is your old. I got bigger, so my scale factor is going to be bigger than 1. So let's say I'm going to pair the 4 with the 8. So new over old. Pair the 18 with the 9. New over old. And then pair the 12 with the 6. New over old. Every one of these fractions reduces to 2 over 1. So my scale factor is 2, as it should be because it got bigger. And then the last one is side, angle, side. It's still the same thing. 2 sides and the angle that's in the middle, just like we did before. So your corresponding sides have to be proportional and the angle has to be congruent. So for example, new over old, so 10 over 5, 16 goes with 8. Both of these reduce to 2 over 1. And this angle's congruent, so I have side, angle, side. All right, so let's determine if these two triangles are congruent, or I'm sorry, are similar. So based on what I know, okay, I know that this angle is congruent to this angle. I know this angle is congruent to this angle because they're vertical. So I have two angles. So that is enough to say angle, angle. Now I just need to name my triangles. So if I said X, Y, Z, X, Y, Z, then X goes with H, Y goes with Y, Z goes with J. So H, Y, J. Okay. The next one, I have 3 sides, so if they all have the same scale factor, then they're going to be side, side, side. So pick the smallest to go with the smallest. So I've got new over old. So 9 over 6, 12 over 8, 15 over 10. And then I'm going to reduce each one. 3 goes into that 3 times and 2 times. 4 goes into that 3 and 2. And then 5 goes into that 3 and 2. So my scale factor is 3 over 2. So they are congruent by side, side, side. So angle 1, 2, 3, 1, 2, 3. So TZB. TXB, sorry. All right, last part. This one is a little bit different because I'm missing these two angles. This is 75 and this is 50 and this is 55. It looks like there's only one triangle there, but I have two triangles. I have two small ones. I have the small one TJP, TJP, where this is 75 and this is 50. Please redraw the triangles when they're like this. And then you've got the big one, which is TAN, and they tell me that N is 55. T is still 75 because it's the same T. So now I need to find out what, since these two angles don't match, I need to find the other angle. So 75 plus 50 is 125. 180 minus 125 is 55. So that makes this angle 55. Well, if that angle's 55, then this one has to be 50 because that one is 55. So that means, yes, these two are congruent by angle, angle. So T, P, J. So T is still 75. The P is 50. The A is 50. And the J is 55. So the N is 55. So you still have to be careful when you order. All right, the last one, it looks like it's going to be side, angle, side. So let's check the ratios. New over old, 15 over 24. New over old, 20 over 32. So new over old, 3 goes into that 5 times. 3 goes into that 8 times. Let's see, 4 goes into that 5 times, and 4 goes into that 8 times. So they have the same ratio. So yes, they are similar by side angle side. So I have K, J, S, K, oops, 1, 2, 3. So C, N, L. All right. See you next week.